everybody for being here. My name is Julio and I will present you my thesis named Automated BIM QA QC Procedures with Practical Application. To start, I would like to start with some key concepts. The first one is that the quality in BIM models is directly affected by the quality of the data they contain. And this is because the model is the context that will transform this data into information. And at the same time, this information needs to comply with some requirements that can be defined by the client, by other stakeholders, or even our organization. These requirements define what, when, how, and for whom this information is going to be produced, and a way to keep the quality in our BIM models is through the implementation of QA and QC processes. One of the most powerful tools to implementing these processes is model checking or model validation, which is actually the process of checking the models for any possible data loss or corruption or incompatibility with the requirements that we were talking about. Therefore, model checking is organized in 3 different consequential phases right now in BIM projects that we can identify as BIM validation, class detection, and code checking. And automated procedures for BIM model checking are involving 3 elements generally, which are software, the BIM models, and rule sets or sets of rules. Once we have done this research and we have these concepts clear, we have a problem statement, which is models with time have passed from being just geometrical representation of what we wanted to build to information databases that we can consult and we will consult during the life cycle of a project. And with this increasing of information, also more and more every time this information needs to comply with more requirements. From the point of view of a design company, the design company is not only responsible to create information, but it is also responsible for checking that information is correct and can be used by other parts involved in the project. And still today, because of the maturity of some organizations is not so high regarding BIM, this model checking is being carried out by manual or semi-automated procedures. And the automated procedures usually are involving IFC format, but to get an IFC, you have to export a model from an authoring tool, and if it is not done the proper way, it can imply some data loss. So the hypothesis is that if we implement automated rule-based model checking procedures within the authoring tool, this can save time from the side of the design company, and it can increase the efficiency on the information production, and this will translate into time saved and therefore money saved also for the client. How do we address this? By defining a workflow to implement automated rule-based model checking procedures for the validation of the alphanumerical information in BIM models from the point of view of the design company. And for this workflow, we have based our definition on the 4 major stages of automatic rule-based model checking that were defined by Eastman. This is an IDF0 diagram for the workflow involving the inputs, the outputs, the controls, and the mechanisms. And this is a more developed version of that workflow where we can see the 4 main activities that we define. The first one will be rule interpretation. Second one would be building model preparation. Third one, the rule execution. And the final one would be the rule check reporting. For the first step of rule interpretation, we would have also at the same time 3 activities that we can identify. First one would be information requirements classification. Second one, project-specific check sets structure definition. And third one, create project-specific rule-based checks. So the step 1 of rule interpretation, we can define it that it is the way that we will translate the requirements from human language to machine language. And these model automated checks should be based on three principles: replicability, modularity, and storageability. The first step the first activity in this step, as I said, it would be the classifying the requirements, so we can see which ones we can implement to be read by the machine. For example, if we have a requirement saying our room should be comfortable, maybe we cannot translate this to computer language, but if we have a requirement saying any room can't be smaller than 15 square meters, probably we can implement this in machine readable language. Second step, we have to define a clear structure that serves our purpose for the checks. So we can define how we want to perform the automated checks. For example, we can base our structure based on the categories we want to check, or we can base our structure in the milestone, in the project stages, etc. And finally, we should create project-specific rule-based checks. And these rules would have like two parts. A first part of the rule would even identify which objects we want to check. And the second part of the rule, the conditions that we want to check for that object. The second step, the building model preparation, would consist on enriching the model with the alphanumerical information, because our objective is to validate the alphanumerical information contained in the model. And this is a possible step that can be automated and should be automated when possible, because we'll know that the human action can imply errors. So if we have a defined database with our requirements, we can make use of scripts or other automated ways to enrich our model in a way that we reduce the human activity the most possible to reduce errors. The step 3 would be like actually the execution of the automated checks, where the tool that we select will take the information from the models and will read the rules that we have defined, so that it will perform a check and say if the objects are compliant or not compliant with the requirements we are checking. Finally, on the step 4, we need to communicate those results from the checks. And for this, we have defined 2 cases of reporting these results of the checks. The first one would be like the information issues reporting, where we would communicate to other project members that there are some issues in our model and corrective actions need to be carried out. For example, we can do this with BCF manager, where we can identify some issues in the model and assign a task to other project member. And we can also have management reporting, where with tools like Power BI, we can create some dashboards and we can use this for following up the project and do some decision making. For example, if we have for 3 weeks in a row that we are having problems with the foundations of the model, the information that is contained there, maybe we need to take some actions. Also, it is worth to mention that even if these steps that we have seen, they could be implemented in an independent way, the most ideal is that they would be implemented into the design processes of the design company. So here we can see a generic workflow where every step can be implemented in a generic process of a design stage, generic design stage. So we can see, for example, for the setting up, we can set up the rule interpretation. When the modeling starts in the authoring tool, we can implement the stage of building model preparation, and for other validation methods, we can also include the rule execution and the reporting. And finally, we would analyze the reports from the check activity. So for the case study of this workflow, we have tried to implement it in a BIM model provided by IBE, which is one of the largest engineering companies in Slovenia. And beside the model, they have also provided the alphanumerical information requirements for the foundation elements of the building. To To implement this workflow, this is the software we have selected, Autodesk Revit, because it is the authoring tool they use. And then to perform the checks, we have selected a model checker for Revit to create the rule sets, the model checker configurator, and for the building model preparation, in order to enrich the model with some alphanumerical information, we can use Dynamo scripts. Finally, for the reporting, as I mentioned before, we used BIM QA, BCF Manager, and Power BI. So for the first step, we see here the information requirements that are ready to be implemented in the rules. We have defined a check set structure that is modular. So for example, we have been checking the category of the elements, different categories. For example, piles, pile caps, pocket foundations, etc. So we can activate or deactivate the checks regarding these elements, because maybe we won't want to check all the elements at the same time, but we will want to check them separately. And with the model checker configurator, we can create the rules. For example, here there is a part of the rule that will identify the object we want to check, and the bottom part of the rule will analyze the information regarding the object and see if it complies with the requirements or not. As I mentioned before, for the building model preparation step, we created some Dynamo script in order to create some parameters and populate these parameters that were not available in the model. Finally, the checks would be performed with a model checker for Revit, where when you are setting up the check set, you can select which checks you want to perform or not. So the check set structure is very important here. And finally, for the reporting, if we identified problems with the information of the piles, for example, we can generate a report and assign it to someone to check this information that is missing. And we can create a Power BI dashboard that will gather information that we want regarding these automated checks. So finally, as conclusions, I would say that the workflow for this case study proves the hypothesis. However, there are some limitations. For example, as I mentioned before, all these steps, the most optimal thing is that they are implemented in the design process of the company. And the first steps of the workflow, if you perform them independently, they take a lot of time. And if we design the good check set structure and the checks, it will reduce drastically the effort we need to use in future projects, because if we can replicate this, it will save us a lot of time. And implementing the workflow for the first time, it takes time, but executing the checks it takes really, it's automated. So every time we perform a check, we will be compensating the time we invested in implementing the workflow. So this is why these workflows or the checks should be implemented as earliest as possible in the life cycle of the design stage. And it is also very important that the company should have very strong modeling and naming standards. And this is because for most of the checks of the information, we can use a regular expression. But if the structure of the information is different every time through every project, it will be very complicated, and it will take a lot of time to perform the same check in different projects. So in general, also as a conclusion, I would say that it is possible in the authoring tool environment right now, with the tools that are available, to check the information available in BIM models, and we can avoid the exporting to IFC in order to perform automated checks. This is it. Thank you very much.